Water is a weird substance. It takes a long time to heat water enough for it to start to boil. But once it does, that water holds on to the heat for a long time before it cools off. Unlike many other substances, water expands when it freezes. Air is trapped in ice, which is why ice is less dense than liquid water and why it floats instead of sinks. Now remember that fact, because I will mention it again in a few minutes, and you'll understand why that is very important. Aside from the sun, the water in the oceans have the most influence on weather patterns and the climate. 71% of the surface of the Earth is covered in water, and the sun's energy is constantly being captured and stored by the oceans and large deep-water lakes all around the world. The ocean holds 1,000 times more heat than the atmosphere, and since energy always flows from warm bodies to cold ones, the oceans heat the atmosphere and not the other way around. Within each ocean there are warm and cold water temperature patterns that form as well. These large regions of warmer or colder than normal water help determine where high and low pressure areas form over the ocean. That in turn affects the flow of the weather patterns all around the Earth. As these ocean patterns shift, so do our weather patterns. Some of these ocean patterns are well known. You may have heard of the El Niño, which is a large area of warmer than normal water that develops in the Pacific Ocean near the equator just west of South America. El Niños put a lot of warm, humid air into the atmosphere. And as you've learned in previous IQ weather lessons, warm and humid air is lighter than cold air, so warmer water promotes lower pressures in the atmosphere above. At times, the ocean water in that same area turns much colder. When it does, it's called a La Niña, and that also changes the flow of weather around the Earth. Colder water promotes higher pressure in the air overhead. There are other warm and cold water patterns that cover vast areas of the oceans. These patterns can sometimes last for up to 40 years before they change. That's why it's not uncommon for some weather patterns to get stuck over a region for long periods of time. Some droughts can last for several years, and very wet and rainy weather can be persistent enough to cause major flooding. The warm phase of the Atlantic multi-decadal oscillation, for example, can lead to more hurricane development. Likewise, the cold phase of the Pacific decadal oscillation can bring warmer winters, with less snow across much of the United States. We don't fully understand how these warm and cold pools of water develop or what causes them to eventually change. The oceans are turbulent and chaotic and so complex that computer models are incapable of properly dealing with how much they affect the weather patterns. One potential factor on the ocean water temperatures may be volcanoes. 85% of all the volcanoes on Earth are under the ocean. Hot magma from these underwater volcanic vents heat the water near them to around 400 degrees Fahrenheit. And these underwater volcanoes can be found in areas all over the ocean floor. There's even an active ridge of volcanoes under the water near the North Pole. We know less about what happens on the floor of the oceans than we do about the face of the moon. The oceans also store and dissolve massive amounts of carbon dioxide. There's 49 times the amount of CO2 in the ocean than there is in the air. Warm ocean water releases carbon dioxide into the air, and cold water removes CO2 from the atmosphere. So large-scale changes in the ocean temperatures have a huge impact on how much carbon dioxide is in the atmosphere. The ocean keeps our planet livable. Even if you don't live near the beach, they affect your weather every day. Remember earlier in this lesson I mentioned the fact that ice floats? Well, if it didn't float, all the ice in the oceans would sink to the bottom, where it couldn't melt, and eventually the ocean would turn to ice and our planet would turn so cold we couldn't survive. So be thankful for the simple fact that ice floats.